To address the need for additional heating in a commercial building with a 400 amp 3-phase 208 volt service, several options can be considered, keeping in mind the limitations of the existing concrete structure and the desire to use 480 volt heaters. One option is to install a step-up transformer. This involves using a transformer to convert the existing 208 volt supply to the required 480 volts for the heaters. This provides the necessary 480 volt power. However, this option adds a significant load, approximately 160 amps for two heaters drawing 36 amps each. This could potentially overload the existing 200 amp panels. Also, it requires the installation of a new 480 volt panel, which adds to the project costs. A second option involves upgrading the existing panels. Instead of using a transformer, the existing 200 amp panels could be replaced with higher rated panels, such as 300 amp panels. This avoids the need for a step-up transformer. However, upgrading the panels can be expensive and time-consuming, requiring a complete shutdown of the existing electrical system during the upgrade. A third option is to consider alternative heating methods that don't require 480 volts. This can include radiant floor heating. Radiant floor heating involves installing heating elements beneath the floors to provide radiant heat. It requires a dedicated circuit. However, this might not be suitable for a concrete building due to the difficulty of installation. Also, consider infrared heaters. Infrared heaters emit infrared radiation to heat objects and surfaces directly. They require specific wiring and may not be as efficient for heating large spaces. Also, space heaters are an option. Portable or wall-mounted space heaters can be used to supplement the existing heating system. However, they typically have limited coverage and might not be suitable for larger commercial applications. Regardless of the chosen solution, there are other critical considerations. It's important to determine the elevator's power draw to ensure the total load, including the new heaters and the elevator, does not exceed the 400 amp service capacity. Since the building is concrete, running new wiring can be challenging. Explore options for concealed wiring where possible. Otherwise, consider using surface-mounted conduits to minimize disruption to the building's structure and aesthetics. Crucially, all electrical installations must comply with the National Electrical Code, NEC, and all local electrical codes. It's highly recommended to consult with and hire a licensed electrician for professional advice and installation to ensure safety and code compliance. To elaborate further on the step-up transformer option, let's delve into the specifics of selecting and installing such a transformer. Firstly, it's essential to accurately calculate the total load that the transformer will need to support. This includes the combined load of the two 110,000 British thermal unit heaters, which draw approximately 36 amps each at 480 volts, totaling 72 amps. Also factor in any additional loads that might be connected to the new 480 volt panel in the future. Oversizing the transformer slightly provides a safety margin and allows for future expansion. Secondly, select a transformer with the appropriate kilovolt ampere or kV rating. The kVA rating is calculated by multiplying the voltage in kilovolts by the current in amps. In this case, the heater load is 480 volts times 72 amps, which equals 34,560 volt amps, or 34.56 kVA. Choose a transformer with a kVA rating that is at least 25% higher than this calculated load to account for inrush current and potential future loads. A 50 kVA transformer would be a suitable choice. Thirdly, consider the transformer's impedance. Impedance affects the voltage regulation and short-circuit current. A lower impedance typically results in better voltage regulation but also higher short-circuit current. Consult with the transformer manufacturer to select a transformer with an impedance that is appropriate for the application and the existing electrical system's protective devices. Fourthly, ensure the transformer is installed in a well-ventilated location to prevent overheating. Transformers generate heat during operation. Adequate ventilation is crucial to dissipate this heat and maintain the transformer's efficiency and lifespan. Follow the manufacturer's recommendations for ventilation requirements. Fifthly, install appropriate overcurrent protection for both the primary and secondary sides of the transformer. This typically involves using circuit breakers or fuses. The overcurrent protection devices should be sized according to the transformer's rated current and the applicable electrical codes, such as the NEC. Table 450.3 provides guidance on transformer overcurrent protection. Sixthly, properly ground the transformer and the new 480-volt panel. Grounding is essential for safety and to provide a low impedance path for fault currents. Follow the NEC Article 250 for grounding requirements. Seventhly, install a disconnect switch near the transformer to allow for easy isolation of the transformer for maintenance or repairs. The disconnect switch should be rated for the voltage and current of the transformer's primary side. Eighthly, label all components clearly. Label the transformer, the new 480-volt panel, and all associated wiring with clear and permanent labels to identify their function and voltage. This helps prevent confusion and ensures safety during future maintenance or modifications. Ninthly, after installation, thoroughly test the transformer and the new 480-volt panel to verify proper operation. Use a voltmeter to check the voltage levels at various points in the system. Use an ammeter to measure the current draw of the heaters and other loads. Use an insulation resistance tester, or megger, to check the insulation resistance of the wiring and equipment. Tenthly, document all aspects of the installation, including the transformer specifications, wiring diagrams, overcurrent protection settings, and test results. Keep this documentation in a safe and accessible location for future reference. Now, let's consider the option of upgrading the existing panels in more detail. This approach avoids the need for a step-up transformer but requires careful planning and execution. Firstly, assess the existing load on each of the 200 amp panels. Use an ammeter to measure the current draw of all circuits under normal operating conditions. This provides a baseline for determining the required capacity of the new panels. Secondly, calculate the total load, including the new heaters and the elevator, to determine the required ampacity of the new panels. As mentioned earlier, the two heaters will add approximately 72 amps at 480 volts. However, since the panels are rated at 208 volts, the equivalent current draw at 208 volts will be higher. The calculation is as follows: 72 amps times 480 volts divided by 208 volts, which equals approximately 166 amps per phase. Thirdly, select new panels with an ampacity that is sufficient to handle the total load. In this case, replacing the 200 amp panels with 300 amp or 400 amp panels might be necessary. Ensure the new panels are compatible with the existing electrical system and meet all applicable electrical codes. Fourthly, consider the physical size and mounting requirements of the new panels. Ensure the new panels will fit in the existing space and can be securely mounted. If necessary, modifications to the existing electrical room might be required. Fifthly, plan the panel upgrade carefully to minimize downtime. The panel upgrade will require a complete shutdown of the existing electrical system. Schedule the upgrade for a time when the building is unoccupied or when downtime will have the least impact. Sixthly, disconnect all circuits from the existing panels and carefully label each wire. Use a wire marker to label each wire with its corresponding circuit number. This will help ensure that the wires are reconnected correctly to the new panels. Seventhly, remove the existing panels and install the new panels. Ensure the new panels are securely mounted and properly grounded. Eighthly, reconnect all circuits to the new panels, following the wiring diagram and the wire labels. Double-check each connection to ensure it is secure and correct. Ninthly, install new circuit breakers that are sized appropriately for each circuit. The circuit breakers should be rated for the voltage and current of the circuits they protect. Tenthly, after the panel upgrade is complete, thoroughly test the system to verify proper operation. Use a voltmeter to check the voltage levels at various points in the system. Use an ammeter to measure the current draw of each circuit. Use an insulation resistance tester to check the insulation resistance of the wiring and equipment. Let's also examine alternative heating methods in more detail. Radiant floor heating offers a comfortable and energy-efficient way to heat a space. However, installing radiant floor heating in an existing concrete building can be challenging. Firstly, determine whether the existing concrete slab is suitable for radiant floor heating. The slab should be structurally sound and free of any cracks or damage. Secondly, consider the type of radiant floor heating system that is most appropriate for the application. There are two main types of radiant floor heating systems: electric and hydronic. Electric radiant floor heating systems use electric heating cables or mats to generate heat. Hydronic radiant floor heating systems use hot water to heat the floor. Hydronic systems are typically more energy efficient for larger areas, but they require a boiler or other hot water source. Thirdly, prepare the concrete slab for the installation of the radiant floor heating system. This might involve cleaning the slab, leveling it, and installing insulation. Fourthly, install the heating cables or mats or the hydronic tubing according to the manufacturer's instructions. Ensure the heating elements are evenly spaced and securely attached to the slab. Fifthly, cover the heating elements with a layer of thin-set mortar or self-leveling concrete. This will protect the heating elements and provide a smooth, even surface for the finished floor. Sixthly, install the finished floor, such as tile, stone, or wood. Ensure the finished floor is compatible with radiant floor heating and can withstand the temperatures generated by the system. Infrared heaters provide targeted heat to specific areas. They are a good option for supplementing the existing heating system or for heating areas that are difficult to heat with conventional methods. Firstly, select infrared heaters that are appropriately sized for the area to be heated. The size of the heater will depend on the size of the area, the ceiling height, and the level of insulation. Secondly, mount the infrared heaters securely to the ceiling or wall following the manufacturer's instructions. Ensure the heaters are positioned so that they will provide even heat distribution. Thirdly, wire the infrared heaters to a dedicated circuit. The circuit should be sized appropriately for the heater's current draw. Fourthly, install a thermostat to control the temperature of the infrared heaters. The thermostat should be located in an area that is representative of the temperature of the space. Space heaters are a simple and inexpensive way to provide supplemental heat. However, they are not typically suitable for heating large commercial spaces. Firstly, select space heaters that are appropriately sized for the area to be heated. The size of the heater will depend on the size of the area, the ceiling height, and the level of insulation. Secondly, place the space heaters in a location where they will not be a fire hazard. Keep them away from flammable materials such as curtains and furniture. Thirdly, plug the space heaters into a dedicated circuit. The circuit should be sized appropriately for the heater's current draw. Fourthly, never leave space heaters unattended. Turn them off when leaving the room or going to bed. Regardless of the heating method chosen, it is essential to consider energy efficiency. Choose energy-efficient equipment and implement energy-saving measures, such as insulating the building and sealing air leaks. Also, consider the building's ventilation system. Ensure the ventilation system is properly maintained and is providing adequate ventilation. Proper ventilation is essential for maintaining indoor air quality and preventing the buildup of moisture and pollutants. Also, consider the building's lighting system. Use energy-efficient lighting, such as light-emitting diode or LED lighting, to reduce energy consumption. To ensure that the chosen solution is safe and compliant with all applicable codes, it is essential to consult with a qualified electrical engineer and a licensed electrician. They can assess the existing electrical system, calculate the load requirements, and design a safe and efficient solution that meets all applicable codes and standards. Remember that working with electricity can be dangerous, and it is always best to leave electrical work to the professionals. Always obtain the necessary permits before starting any electrical work. This will ensure that the work is inspected and approved by the local authorities. Keep accurate records of all electrical work. This will be helpful for future maintenance and repairs.